Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on sampling distribution of means. This is an introduction to the sampling distribution and to the central limit theorem. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. First, we will need a quick review of our notation. Please learn your notation. It makes learning statistics easier and more manageable. We have two things that we'll be talking about in this video: population and sample. On the left, we have your population size, which is a capital N. On the right, we have our sample, which is indicated by a lowercase n. Population mean is indicated by the Greek letter mu, and the sample mean is indicated by x with a bar over it, which we read, of course, as x bar. Sigma is the population standard deviation, and S is the sample standard deviation. One way that I keep straight which symbols are which is that the Greek letters mu and sigma both are population, while the English letters x and s both go with the sample. And N, being capital, is larger, therefore is the population, and the lowercase n would go with the sample. It's not a perfect solution, but is one way that I help keep this straight. Here we have a population of fish with their weights. Their weights are in pounds and are indicated on each fish. We're asked to find the population mean standard deviation for the weights of the fish. We will need to find N, mu, and sigma. We will do this with the calculator. Input the population data into your calculator. You will press Stat and then Edit under the Edit menu. Then you will input each of the weights under List 1. You will not see all of those listed on the screen here. There are extra numbers at the bottom. Please double check your data, because if you put the wrong data in, you will get the wrong answer out. Then you will press Stat, over to the word Calculate, and choose one variable stats. Then you'll need to choose List 1 because our data was in List 1. Press Enter and the calculator gives you the following screen. Here we can find the information that we need. Again, remind ourselves that we're looking for capital N, our population size, mu, and sigma. N equals 10. This is really our population, since L1 is a population with N members. The calculator doesn't know whether you've put a sample or a population, so it will label everything as a sample. You have to know which you've put in. So this is a calculator labeling error. This is truly our capital N, or our population size. N is 10. We could have also just counted the fish. X bar is the mean. This is really mu, since L1 is a population with equally likely members. Again, a calculator labeling error, because the calculator does not know whether you've inputted a population or a sample. So our mu is 5.22. There is a difference in how we calculate a sample standard deviation versus a population standard deviation, so both are shown and we have to pick the correct one. Since this is a population, we'll pick sigma. The population standard deviation, since L1 is a population with equally likely members, gives us a population standard deviation of 1.2221. Ms. Borlaug rounds to 4 decimal places. Please follow your teacher's rules for rounding. And that finds the mean and standard deviation for the weight of the fish, or the population mean and standard deviation. How many ways are there to select 4 fish from our population? Well, that would be a combination because all of the fish would be in the group and the order is not important. There are 10 members and we're selecting them 4 at a time. We can also put that in the calculator to find our answer. 10, then NCR 4, and that would give us 210. Part C. Take a simple random sample of 4 fish and then write a few sentences describing how you took the random sample. Circle the fish selected. Well, the first step would be to number the fish. As the PowerPoint does that for us, and the order in which you numbered them would not matter. We simply must number the fish. Then we're going to use the calculator command random integer, and in this case our numbers are from 1 to 10. And we want to do this to get a random sample size of 4. In our calculator, we will press enter until we have 4 unique numbers. We will ignore any repeats. We will circle then the selected fish. Fish 7, 10, ignore the repeated 7, then fish 4 and 1. That gives us a sample of 4. This is my random sample size of n equals 4. For your class exercise, why don't you try and circle 4 of your own samples? And you can pause the video to do so. Back to our sample, we want to find the sample mean and standard deviation of the weight of the fishes that we chose. Notice the difference in the notation, lowercase n, x bar, and s. We'll input the sample data into the calculator, pressing Stat and then choosing Edit under the Edit menu. In this case, we'll clear out any old data and input 5.5, 7.0, 7.1, and 5.8. That gives us the 4 fish that we selected. Do one variable stats on list 1, remembering to press Stat, calculate, and then one variable stats, then second list 1. When we press enter, that will give us a sample size of 4, a sample mean of 6.35, and a sample standard deviation of 0.8185. You can pause and find the sample size, mean, and standard deviation for the sample that you found in exercise 1. Let's look now and calculate the sample error for the mean. The sample error for the mean simply takes what we found in our sample and subtract it from the population sample mean, not the population sample, but takes the sample mean minus the population mean. Here are our answers to the previous parts. So we will simply take 6.35, our sample mean, minus 5.22, the population mean. That gives us 1.13. A positive sample error for the mean shows that the sample mean overestimates the population mean. A negative would have shown that it underestimates. For class exercise 3, you can calculate the sample error for the mean for your sample. Now that we have back to our sample, we can also calculate the sample error for the standard deviation. The sample error for the standard deviation takes the sample standard deviation minus the population standard deviation. Apparently that's a tongue twister. Again, our results from our previous problems. So we will subtract 0.8185, the sample standard deviation, minus 1.2221, the population standard deviation. This gives us a negative 0.4036. A negative sample error for the standard deviation shows that the sample mean underestimates the population. And I think this should be shows that the sample standard deviation underestimates the population standard deviation. And a positive would show that it overestimates. Again, those should be standard deviations and not the word means. And you can do the same to find the sample error for your standard deviation in your sample. A last class activity, because this activity was actually meant to be doing for an entire class, is to have each student put their sample mean x bar from your exercise on the graph below and have each student in the class do so. Since we cannot do this for an entire class in our video, you may wish to go back and do multiple sets of samples and place each of those sample means on the graph to see how it would work as you do it, to see what kind of answers you get. But by the magic of the video and Ms. Borlaug, we can look at all 210 examples that she has graphed on the second graph below. So the first graph is a graph of the 10 individual fish. The second graph is the graph where the sample size is 4 and it's the mean of each of those samples, all 210 possible sample sizes, samples of size 4. Notice, what do we observe about the two different graphs? What's the same and what's different? You should notice that in the samples, are much closer together and that the shape of those is becoming almost like a normal curve. And as the shapes get closer, that kind of indicates, since the points are closer together, the shape is closer together, that their standard deviation would be smaller. What would be the same? Well, if you kind of estimated where the mean of both graphs were, you could see that the mean, or I hope you see, that the mean would be approximately in the same place for both graphs. We will look at more at this in some future videos. I wish to thank you for watching.